Welcome, everyone. I'm Tom Crummell, co-director of the Stanford Biodesign program and also chair of the board at the Fogarty Institute, so I kind of wear both hats for the co-sponsors for this lectureship. And so on behalf of my co-hosts, Andrew Cleland, Paul Yock, Tom Fogarty, welcome. Thank you all so much for being here. We're so delighted that so many people have decided to join us for this 20th Fogarty lecture. Dr. Fogarty and I were talking earlier that 20 years ago at the Lucile Packard Children's Hospital Auditorium where we had the first one, there were probably 30 people there, and Tom was the featured speaker, and it's been off to the races ever since. I think the tremendous attendance today speaks volumes about three things that are confluent. One is the lectureship and its 20th anniversary, and for those that have been to a number of these, it's like great to see your friends and colleagues. It's always a brain stretch, and so, we're looking forward to many, many more. It also speaks about the Silicon Valley medtech ecosystem, which we were chatting with Josh and with John, is really in a good place and probably we could imagine even resurgent. And lastly, I think it speaks a lot about our speaker today, John Adler. We'll talk about his time at Harvard, but John's been here since the mid to late 80s and, really is a citizen of the Valley and the kind of person that we all turn out to see. We did the lectureship together 20 years ago with a concept that there was a value, not just in talking about academic stuff, but talking about how real patient problems get solved with real technology and how docs, engineers, and business people make that happen. And so the 20th series, really aligns with that. The lectureship also celebrates the historic ecosystem in the Valley. Many of you come from business, engineering, regulatory, an assortment of manufacturing, and that's, I think, in many ways what has made the Valley such a hotbed for medtech development and innovation. And lastly, we do this lecture to celebrate the fantastic career of Dr. Tom Fogarty that is now tracked over 50 years. Dr. Fogarty's bio is in your booklet, but just to hit the high points, in 2000 he received the Lemelson Award from MIT. That's dubbed the Oscars for Innovation. Not bad for starters. In 2001 he was inducted into the National Innovators and Inventors Hall of Fame. Edison, the Wright brothers, you get the picture. 11 years ago, Dr. Fogarty took his lifetime of experience and founded the Fogarty Institute, a not-for-profit. So Dr. Fogarty can indeed manage a not-for-profit, for those that doubt that, medtech educational incubator. And after 11 years, it's really become a preeminent part of Silicon Valley medtech ecosystem, mentoring and teaching the next generation of Tom Fogartys under Andrew Cleland's remarkable leadership, and Andrew is sitting with Dr. Fogarty. In 2014, Dr. Fogarty received the National Medal of Technology Innovation from President Barack Obama at the White House. Despite Dr. Fogarty's presence, it was a saner time in the White House. Tom's bio is in the booklet. Please read it. It, I think, is a source of inspiration for all of us, for the young at heart, including Tom. And if you look at the previous 19 lecturers, it is a who's who of the world's biggest contributors in medtech innovation and in invention and creativity within Silicon Valley. This year's 20th Fogarty Lecture, Dr. John Adler, is a most worthy addition to the list. John's a distinguished graduate from Harvard College and Harvard Medical School, trained in neurosurgery at Boston Children's, the Brigham, and the MGH. Amazingly, Dr. Adler has been able to recover from that big dose of Preparation H. Inside joke. Good. In '85, John had a seminal experience when he did a one-year fellowship in Sweden with Lars Lexel, who invented the gamma knife. And that was a big frame bolted to your head, and that was essential to target the known position of the lesion and the radiation beam. John saw an opportunity to improve it, to eliminate the physical cage of the bolt to your head, that would eliminate the need for understanding the position of the lesion, and focus the radiation beam based on the patient's anatomy, not on an external frame. That insight was profound, and there was a confluence between the insight, leaving Sweden, and ultimately coming to Stanford in 1987. John worked with the faculty in the School of Engineering to build a prototype, and shortly thereafter started pitching the concept. Needless to say, it was rejection, 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 followed by rejection. The usual suspects said, no way, too complicated, too long, regulatory, radiation therapy, God help us, that will never amount to anything. So, like any good entrepreneur, John raised $800,000 from other neurosurgeons who got it, friends and family who got it, and started a little company called Accuray in 1992. He created the CyberKnife frameless stereotactic radiosurgery system to commercialize the invention, and up till 2009, he served many roles at Accuray beyond founder, including CEO, chief medical officer, and chair of the board. To date, just to put the scope and scale of his accomplishment in perspective, Accuray technology has, number one, been used to treat more than 1 million patients. That, ladies and gentlemen, is leverage, right? One doctor, if a really busy doctor might treat 10,000 patients in their lifetime. 1 million patients have been treated with Dr. Adler's device specifically, and even better, most modern radiation equipment now incorporates John's basic idea for image-guided targeting, an incredible leverage of a fundamental concept that he saw and something that could be done better. In 2014, John founded Zapp Surgical Systems with a mission to advance cancer treatment for all humanity. His invention, the AppX, received FDA clearance 2 months ago in September of 2018, a big milestone for Zapp Surgical. John is the proverbial Renaissance multi-talented guy. In addition to his radiosurgery expertise, he serves as a co-editor-in-chief of Curious, C-U-R-E-U-S, the world's only multidisciplinary, free, open-access medical journal, which now publishes more than 2,000 peer-reviewed articles every year. And perhaps unrealistically, John still wants to be a big wave surfer. Throughout his career, Dr. Adler has excelled. He's a recipient of many awards, recognitions, and honors. His bio is again in your program booklet, but the inaugural Ideals of Entrepreneurship Award, Emerging Entrepreneurs in Biotech Award, the Suitors Memorial Award, and perhaps most importantly, in April of 2018, this past spring, the American Association of Neurologic Surgeons presented Dr. John Adler with the Cushing Award for Innovation, one of the highest honors in neurosurgery. Dr. Adler holds over 20 patents, is a recipient of multiple awards. In summary, John Adler is recognized worldwide as a superb neurosurgeon, inventor, and leader. He is both a thinker and a doer. There's nobody better to deliver this year's Fogarty Lecture, the number 20, but John Adler, sometimes an entrepreneur, but always a doctor. Please welcome John.
As they say, my mother would have believed every word. And as Tom once said, and I still love it, he said, awards are a lot like hemorrhoids. You remember? Any asshole that hangs around long enough is sure to get a few. Anyway, this is among the greatest honors of my life. I kind of a hometown boy. It's good to connect with many people who have helped me in my life. And I'd like to sort of recount some of the things I've done and the seminal role that Stanford played in making that possible, and try to reflect a little bit on what I've learned. And in the end, there's not much I'm going to tell people like Tom, the 2 Toms squared, or Josh, but there may be some young entrepreneurs here who are thinking about what the future might lie before them, and especially if they're a physician, I'd love to tell them a little bit about my own life. So why the title? Well, I was with some family this past summer, and my sister-in-law, we were with a group of people, and she was introducing me, and she said, well, here, my brother over here, he's a lawyer. Brother over here is a doctor. And John, she said, he's a businessman. And I said, shit. I said, I've never been more insulted. And I say that tongue in cheek because obviously the world needs great businessmen. But in the end, what's always driven me in my efforts has really been to fulfill my mission as a physician. So with that, I'm going to use a little of Elon Musk in my talk because, no, it's not because there's always a joke to be had, but no, I think he is really the greatest innovator, the greatest entrepreneur of our generation. But of particular interest, he has recently given us all a window into what the life of an entrepreneur and innovator is. So recently, this is a tweet, he said, someone asked him about entrepreneurship, and he says, the reality is great highs, terrible lows, and unrelenting stress. This is Elon Musk saying that. But I don't think people want to hear about the last two. And he's right. We painted this pretty picture of entrepreneurship and told myths about what a glorious life it can be. But so much of it is really, really hard. And that's going to be much of what my story is about. So I want to contrast innovation with entrepreneurship. Innovation is that great idea, that perfect moment. And I didn't mean to be, I hope that this is not a Me Too movement, but it's really about how simple it is to be an innovator, but to bring a child into the world. And this is not my child. I want you to know this is my new grandchild. This was a chance to bring my grandchild into this story. But to raise a child, to take them through life and work and difficulties, how hard that is. And that's what entrepreneurship is like. And while I celebrate both, I'm going to particularly talk about entrepreneurship. So Tom said all these nice things about me, and let me paraphrase him. I think he said something that's amazingly eloquent. He said, in the operating room, more lives are saved, more diseases are cured, more suffering is relieved, more function is restored than any other place in the hospital. That's where surgeons and other proceduralists deliver. And that's where we medical device innovators deliver. No one wins any Nobel Prizes. No, it's kind of unheralded. These are quiet little events that have happened over generations. But it means today that literally hundreds of millions of patients every year have surgery and do okay. They survive. The accomplishments are on par with eradicating polio or smallpox, but it doesn't ever quite get that notoriety. But we're going to celebrate that as I go forward. And what drives surgery, what drives interventionalists? It's our tools. Whether 6,000, 7,000, 8,000 years ago, some Inca was chipping away at the skull to relieve a subdural. Or Harvey Cushing, that's who that picture is, who really transformed modern surgery with Bovey, an engineer, who showed him how electric cautery worked. Suddenly, it made surgery that was near impossible everyday events. And this is the legacy in which we continue. For surgeons and proceduralists, our needs assessment starts in the operating room. And of course, the Biodesign program emphasizes the importance of inventing, creating things that the world needs. That's what the needs assessment is about. But at the same token, do we implement trivial inventions, or do we try to take on some of the toughest tasks in medicine, like glioblastoma? So in my world, I've done a little of both, and I figure I'd touch on some of the more simple innovations, which are fun and joyful experiences, and just to showcase a little bit of what I know. So in the early 1990s, the world of intraoperative image guidance was starting to emerge, or being conceptualized. And so together with a team from a small company called Radionics, we made really the first image navigation system for the operating room. And this was a short-lived product. I think I made a few $1,000s off of it in consulting fees. Largely contributed the software with a former chief resident of mine who helped make the technology. And we didn't have the right invention. We used this digitizing arm in space. It was supplanted eventually by three-dimensional digitizers using infrared light. But the legacy of this device is really what impacts every operation done in a neurosurgical suite today, and most NT operations and more spine operations. The legacy of this is much of modern surgery. So while my contribution was minor, certainly the impact in the world of surgery has been great. Here's another little tool that I've recently been involved with, which none of you have heard about yet. But is Jeff Schlosser here? There he is, okay. Jeff was my grad student, and God bless him, he wanted to make an impact in the field of radiotherapy, and had an invention that was cute but going nowhere. But I was too kind to say that because he's my student and forever he's right. But I tried to guide him, and he was trying to do what he thought would eventually work. And in the process of trying to figure out how to hold an ultrasound probe during a radiotherapy procedure, he came up with something, what you see here, more or less. It was a instrument holding tool. And immediately, because I am a surgeon, because I am a doctor, I could see that there was great application in the field of surgery. And so this idea has been recently commercialized, and it is my prediction that in the next decade, there won't be an operating room in the world that doesn't have a couple of these. It's a way of holding an instrument very precisely with just a touch of a button. Again, I was just part of the innovation process, not really part of the commercialization process. My longer-term needs assessment really started probably when I was in college, drinking too much beer and other things, sitting around watching Star Trek, and couldn't help but be amazed at what they postulated brain surgery or surgery might be like in the future. And it's interesting to note that that structure there they have looks a lot like a gamma knife helmet. But I'm sure that I internalized during those college days what might be the future of medicine. And I'd like to then paraphrase somebody else who impacted me, again, Harvey Cushing, who we surgeons have always defined ourselves by what our hands do. But arguably the greatest surgeon of the 20th century, Harvey Cushing, said someday, I'd like to see when somebody be appointed a surgeon somewhere who had no hands, for the operative part is the least of the work. It's worth reminding us surgeons. So anyway, I toiled away during residency at Harvard, and it was not an uncommon event that late Friday afternoon I'd get a call, my beeper would go off, and I'd get called to the oncology ward saying, Mr. Jones, who has metastatic cancer of the spine, has been getting radiotherapy for the last couple of weeks, is now going paraplegic or quadriplegic. Can you do something? And so that, of course, meant that Friday night, into the early Saturday morning was spent trying to decompress him, usually with an operation that was totally futile, usually knowing, as I look into the face of this guy, knowing that now I'm just going to let you die with a big slash down your back. But it was the best we could do. But it left scars. As much as I failed to help my patient, it scarred me, realizing we got to do better. This is not the way to do medicine. Of course, I had no idea where my path would take me. And then I stumbled into Stockholm, Karolinska, and worked with Lars Lexel, who I think now is being recognized by many as one of the great minds of neurosurgery of the 20th century. And I was swept away by his way of looking at the world. I had just come from Mass General, MGH, man's greatest hospital. Man's greatest hospital. Or so I believed. But then I saw near miraculous things happening at the Karolinska under his guidance. Literally almost outpatient procedures happening for the same patient who would literally have sat in the ICU for a month after a pineal region tumor, for example. I couldn't believe it. And radiosurgery was so simple an idea. If you knew exactly where you were in the human body, you could just shoot large numbers of beams of radiation through the same target, concentrate the radiation like a magnifying glass concentrates sunlight, and you had a surgical tool. And Lexel conceptualized this in the 50s and then made his gamma knife in the 70s and 80s. He made it happen. And there's his gamma knife. And this is what happens with radiosurgery. This guy didn't like the frame on his head, but damn it, he was grateful that literally one 30-minute session, and your tumor gone. You don't open the head, the tumor's gone. And it happened literally within a few weeks of this event and would last, long-lasting. This is what radiosurgery was, all non-invasive. Of course, what young guy or young gal wouldn't be swept away by this? So I came to Stanford, and I said, well, can we do better? Can I do better? I want to be part of this. This is just too cool. This is what Bones McCoy would embrace, in Star Trek. I like this. And so I put together my team of merry men and scrapped together, and we'll talk a little bit more about it, and treated my first patient in June of 1994 with what was totally a Heathkit radiosurgical system. But for the first time ever, we used imaging to precisely guide a therapeutic radiation beam. And it opened up the possibilities now of not just treating the brain and head and neck, but going anywhere in the body. And that really was the agenda from day one. And it was quite a path getting there. And we'll talk a little bit more about it. And today, this is what the technology looks like in the right side of that slide. Well, what did we accomplish over the years? Well, it started with that one patient. It was I could have easily done it with a frame in 10% of the time. In fact, like most great interventions, initially it was almost a step backwards. But what it has meant is ever since then, we're now treated more than 1 million patients. Here we are. This is a Stanford student I treated about 10 years ago who was quadriplegic when I saw him following a rupture of an AVM. Had really, prior to the CyberKnife, he was looking towards a life of quadriplegic because we had no treatments. And there you see he's hiking in Yosemite or somewhere up in the high country. And today we have, well, by the way, he's a Harvard lawyer now. I don't know if that's good or bad. But today, there's more than 350 CyberKnives around the world, and we've treated more than 1 million patients. And as I stand here right now, I know somewhere in the world there's dozens of patients maybe being treated. And it's a good feeling. Well, I've only been a minor contributor here, but I want to give a shout out to Tom. When the CyberKnife was kind of getting going, and we're starting to have a lot of clinical success treating outside the brain, a cardiac surgeon, Alfredo Benetti, from Argentina came and said, you got to meet with me. I have a great idea. I've got a great idea. It's probably a bad accent. But anyway, I met him in Southern California one day, and he said, we should treat the heart. We should treat the heart for atrial fibrillation. I said, really? I mean, in the field of therapeutic radiation, that's heresy. That's how you kill people. For those of you who don't know, therapeutic radiation with linear started here at Stanford. One might argue it is the seminal creation in medicine of Stanford University Medical School. But what they did is when they invented it in the late 50s, early 60s, they treat a bunch of patients for Hodgkin's disease and cured the first cancer. But they also, in the process of giving mantle radiation, irradiated the heart, led to lots of cardiac complications. And for the better part of the past generation, irradiating the heart was heresy because it was a way to produce coronary artery disease and death. And now comes along this genius cardiac surgeon who actually invented, I guess, the single vessel bypass operation, some wonderful things in cardiac surgery, wants to treat the heart. And so we sat down one afternoon at USC and we kind of reasoned out what this might be. And I said, this almost makes sense. And I thought, left well enough alone, gave him some ideas. About a week later, he's filed a patent. I should have been on it, but I don't care. But he started the process of invention, using the idea being to take the CyberKnife and use it as a ablative tool to manage cardiac arrhythmia. Now, the company has had a difficult course. It is probably, at the moment, it's not solving the problem. But in the course of implementing this technology, several dozen patients have been treated, and the results have been near miraculous. And so I believe that ultimately, the possibilities of this technology are huge, and that radiosurgery with the CyberKnife is not going to just impact cancer. It has this huge potential impact in the world of cardiac arrhythmias. I've also done what is my most unusual company, which is around the journal Curious. Most of you don't give medical journals a second thought. And yet each and every one of you, your lives are impacted by medical journals. Medical knowledge is at the core of everything we do in all of healthcare. And yet we leave it up to this broken, corrupt industry to curate and disseminate the medical knowledge that we generate for free. And around it, they build this huge paywall, making it impossible for most of the world to lack access to journals. Most of the world. When I say most, I mean like 99% of the world doesn't have access to medical journals today. And this is like, should be life or death. It should be almost a human right. But the world has not made that possible. In fact, places like Stanford make it worse because we so venerate the big institutions of journals, like the New England Journal of Medicine and Lancet, which are 200-year-old institutions, and JAMA, et cetera. And Elsevier has built this big paywall around the knowledge that we generate. Well, Curis' intent to sort of destroy that model, to change it, understanding that knowledge should be a community human right, but equally important that it can be monetized in different ways. And very much, Curis is a child of the Silicon Valley, a child of the social network revolution that took place around here. And I give credit to my son, who, developing his own startup, Trip, showed me what it's like to be in the internet world. It gave me maybe the courage to try it myself, no matter how foreign it was from my world of medical devices. And to this day, Curis is charging along. My co-founder, Alex Milosevic, we're publishing over 2,000 articles a year, and the hope is that someday we'll be publishing 2 million articles a year, and that this will become the go-to, not a journal, but the go-to source for medical knowledge. So along my career, I had some audacious ambitions, and as a result, I've had kind of a crazy path. What I've learned is that, yeah, there's some easier medical devices, but if you get involved in high-risk medical devices and static cosmetic procedures and you kind of go where there's no clear regulatory predicate and there's no defined reimbursement, it can be tough. And I'm going to be showing you a little bit about it. So at Accuray, this is the time course I went through. You can see it's virtually almost 20 years, but from the formation of the company, it's 17 years until we did an IPO. We ran out of money repeatedly. I'd wake up fretting what the next day was going to bring me. I'd go to bed worrying that the next morning it was going to be equally bad if I was lucky enough to sleep. It was difficult. It wasn't for friends. If it wasn't for probably the ecosystem of Stanford, this would have never happened. And it was also a more permissive time at Stanford where an academic could more easily straddle the two worlds of commercialism and academia. And only because of this place was I ultimately successful. But how bad was it? Well, for 4 years, I had literally no money, almost. We would pass the hat at a board meeting to raise $20,000 or $10,000 from two of us board members, and that was enabling us to pay the payroll that we owed for 2 weeks ago. How bad was it? Well, we got multiple dunning notices from PG&E saying, if you don't pay your damn power bill, we're turning you off in 24 hours. Could it be that bad? Many friends say, no, it couldn't be that bad. No, it was worse. It was terrible. It was a joke that we were the company, it was Sand Hill Road said we were the company that just wouldn't die. That was our rightful place. But we hung in there, and whether you define success this way, it was a fun idea that, everyone wants to see, their company logo on, the NASDAQ billboard. And that was fun. Although, for the record, I never went to this party. I was selling my product in Portland, Oregon. Customers came first. Do you define success this way? I mean, in the end, I'm delighted that the CyberKnife has treated more than 1 million patients, but is it even more important that image-guided radiation techniques that are now commonplace on all therapeutic radiation devices? And literally, we're treating more than 1 million patients a year. This is really how all radiation is going to be done and is being done. Well, I liked it. It was fun. I had a good run. However, radiosurgery, to me, failed to achieve a lot of its potential. I thought this was a revolution that should represent one of the most important events in healthcare in the last generation. I believe this field of radiosurgery is the equal of the genetics revolution, is the equal of targeted therapies, immunotherapies, is the equal of mitral valve, minimally invasive mitral valve replacement. But what I thought didn't much matter. The world didn't quite recognize my accomplishments to the extent I thought they would. But it didn't make sense. Here we are, the ultimate medicine, no pain, fast, outpatient, highly effective, with very low risk. What can't you like about radiosurgery? Well, it did impact neurosurgery. Today, radiosurgery is the most common operation done for brain tumor in the United States and Japan and much of Europe. We're treating more than 150,000 patients every year. Worldwide, we've treated more than a couple million patients over the last generation of product. We're now increasingly recognizing not just some, but the vast majority of the most common brain tumors, brain metastases, should be treated with radiosurgery. And all this seems to work like a hand in glove with immunotherapies, which of course have us so excited about. Maybe, just maybe, we're starting to see how we're going to cure not just some, but all cancer. But as I looked around the world, this miraculous treatment, I was realizing that more than 2 million patients every year with just brain and head and neck tumors, 2 million patients every year with brain and neck are not getting this procedure. Why? If this is so wonderful, why are they not being treated? Well, for starters, the equipment is the most expensive equipment in healthcare today. More expensive than your Da Vinci robot. It's madness in some respects. Moreover, the equipment requires a very expensive and complex radiotherapy vault, which can be $1 million, $2 million, $5 million, in New York City, $10 million, $15 million. Very expensive. And most radiosurgical facilities are designed for radiation oncologists, and they treat the brain, the head, neck, the kidney, the prostate. And so they immediately go to the radiation therapy department. And the nurse and the surgeon says, who needs this? I'm going to go take the patient to the operating room. Or so expensive and so out of sight. Many patients in the world don't have access. 2 million patients a year. So in the end, it was my opinion that because my technology, and that of the rest of the industry, was so expensive, so complex, the world didn't have access to it. 90% of the world. And so my mission was, can I change that? Well, that was an exciting idea. Wow. Startup life. Yeah. Cool. But then I started thinking about it. Oh, shit. You're just always plagued. Am I crazy or what? My family thinks I'm crazy, but now even I think I'm crazy. You know that you're always on the cusp of failure. I mean, failure is your friend. You go to bed with failure, you wake up with failure. And at 10-minute intervals, your best employee comes in and tells you why you're failing yet again. Moreover, people betray you, and you feel betrayed, maybe not, or you must betray. It's brutally, emotionally. Your endurance. Yeah, I thought, how many surgeons here? How many surgeons in the audience? You know, you think it's tough. You know that residency, one of the toughest things you've done in life. And it was. Don't get me wrong, I trained at the Brigham. It was hell every other night. But you kind of know, if I put my 7 years in, and all these other monkeys I work with, if they can do it, I can do it. 7 years and I'm done. I'm free. The trouble with a startup, you don't know if it's 7 years, 17 years, 70 years. You just don't know. And so, how do you know what your endurance is? If I climb Mount Everest, I say if I go to 28,000 feet, I'm at the top. But you don't know. And you might get lucky. You might be one of these people that the Valley loves to celebrate and the news media talks about, some darling, 27-year-old who just sold their 5th company for, $10 billion. But that really, really, really is the exception in medical devices. That's not how this game works. You don't do it for the money. So all the world is going to fight you when you start doing this because there's a vested interest everywhere. I'm convinced that if you came up with a cure for cancer tomorrow, everyone would try to destroy you because there's too much of an industry around cancer. And they all deny it, but it's true. And yet, every time you just feel exhausted and you just don't want to go forward, you just do. Who the hell signs up for that stuff? Well, entrepreneurs do. So anyway, medical devices are exceptionally bad. You need so much money to get them started. I mean, I'm jealous of the IT world where some kid in his college room with, a server and, can suddenly, rule the world. Turns out to be the richest man in the world almost. But that's IT. It's not medical devices. Moreover, every barrier, all kinds of special barriers, whether they be the FDA, which is really not the worst organization. Believe me, the FDA in the world of commercializing product is not the biggest problem. Much more reimbursement. But you go around the world and you got to get now CFDA clearance. You know what it's like to get Chinese? It's one way Trump is right. CFDA is killer. You need to spend literally 10 years before you know what you're doing, before you really have a clear product you can sell. Anyway, as they say, the moth cannot resist the flame, and I had flame, and I figured I really needed to investigate. Yet, I had an out. I had this cool idea, and I explained it to Varian. And I needed their linear accelerator, and I went and talked to them. Went to talk to the CEO, and I said, could you help me make this linear accelerator? I think I'm going to try to make a new device. And after dancing back and forth for a few months, CEO, who I like, the device guy, product guy, said, Adler, we like your energy and we like that product. Come join us. And here's $1 million a year salary. Hey, not bad. I suddenly had a place to go, a protector, a good salary, and a dream that maybe they'd listen to me. No. After a couple quarters of bad earnings, something needed to be cut. What does a traditional company cut? The first thing they cut is innovation. They cut me off at the knees. At that point, I've given up my Stanford professorship. There's no going back. But by luck, I did find a benefactor in Terry Guo, Gotay Ming, and Foxconn. But anyway, what I experienced at Varian was so depressing and so argues why we need innovation in startups. I call Varian a black hole for innovation. It sucks it in, you'll never see the light of day. It's sad. And yet they have the temerity to put this big sign, transforming cancer care. So much energy at Varian was put into destroying technology outside their universe. That's why we need the innovation that we see here. So Varian dumped me and my baby, and I was depressed. I wasn't clinically depressed, but mortifyingly sad. My mother died that year, and I just felt hopeless. Hopeless. But I had this idea. I even had funding. And so, as much as I despaired being a CEO and entrepreneur again, I did it. And so this new generation product, the Zapp X, is the first of its kind, low energy, self-shielded, specialized surgical robot just for neurosurgeons and for head and neck applications, although we work joyfully with all radiation oncologists to be part of our team. It's tended to be simplified so they can be physician-centric. And most importantly, tend to be low cost. Instead of the madness of the arms race, especially in radiation, where now you can buy a proton beam or carbon. Stanford, they want carbon because $100 million isn't enough. $250 million must be better. There's no clinical evidence. No clinical. But that's the madness that too much of the medical device industry is engulfed in. And I wanted to do something lower cost to treat the 2 million patients who don't have treatment every year. And so this is what we created. It's a big structure. that mechanical device that moves all the critical elements for precision radiation in space, at the same time shields the operator from the effects of the radiation, allowing you to install this machine without a radiotherapy bunker and put it anywhere. The devices open up the field of radiosurgery to treat those 2 million patients who every year are calling to me. There's some cool little attributes to this technology. The way we shape the beam is cool. The way we target is cool. The way we shape the dose of radiation is cool. But in aggregate, it's a best-in-class technology. I'll just kind of show you the mechanics. The mechanics are kind of complex and interesting. It looks like a big gyroscope, a nested bearing within a bearing, and it allows us more angles of attack to concentrate the radiation more effectively. And the beam itself is quite special in that by being lower energy, it allows even a sharper blade, in effect, a sharper dose gradient. Can I? And those what it looks like at the factory in San Carlos after we try to figure out what a customer site might be like. It looks like a big CT or an MRI scan. You can conceive of this being on the ground floor of your clinic. I would like to think so. And so very importantly, I tried to learn some lessons from the giants of Silicon Valley, just specifically Intuitive Surgical. When Intuitive Surgical introduced a consumable, and I was in a horse race with them, I figured, that's crazy. You don't need a consumable. Well, damn it, if you're in the medical capital equipment business, you need a consumable. And so I've introduced here, in part of my product is a real-time dosimeter, first of its kind in the therapeutic radiation industry, and hopefully a first-of-a-kind business model to build not just a product in a company, but a successful product in a company, to keep going. With my compatriot Mohan somewhere in here, we're building a best-in-class kind of software platform to make Silicon Valley sensibilities of design. Here we live in the most vibrant software community in the world, Apple, Google. Yet the software that most radiation oncologists use is from the dark ages, from the Unix era, from the Fortran era. And so I've been very proud of what's come along. So this is kind of what the new generation AppX does and kind of a little bit how it works. So it's a first of its kind, brain and head and neck. There's a nice soundtrack that goes with it, but just imagine me playing an upbeat kind of tune. So I won't sing to you. But the patient goes totally in the machine, yet it's not claustrophobic. And inside this machine, you can see where the operator, for the first time ever, an operator sits right next to the machine. And inside the machine, which is kind of open up and airy, not like an MRI scan, we are able to both accurately target where the patient's head is positioned in space, move the patient in three-dimensional space, and then hit the target with 2 degrees of rotational directions. And in effect, concentrate the radiation very much inside the tumor. Here, maybe this is. You need a little upbeat music. But in the end, watch where this position, this isn't in your radiotherapy department anymore. This is in the middle of your clinic. And that's the idea, to break down the barriers to radiosurgery, open it up to those 2 million patients a year who beckon to us. And that's my action potential logo. See, only a surgeon would think of that. So anyway, my goal is to rebrand therapeutic radiation, open it up to the world. And what you see there on the right is what our first facility in Wisconsin, which is kind of a showcase site, Racine, Wisconsin. Well, I'd like to think that going after brain tumors is a big story, and I'm excited to be treating someday those 2 million patients. Now that we've got 2 facilities installed, we have a long way to go. But by the same token, I've been intrigued by the fact that the great unmet needs in medicine today are not cancer. They're psychiatric diseases. The the World Health Organization has decreed that chronic pain, addiction, obesity, these are the big unmet needs of medicine today. And I've been intrigued also by the idea that maybe the work I'm doing is relevant. And so I've adopted, based on experience with some early patients that I treated with the cyberknife at Stanford who had intractable depression, And I'm interested also in the tens of thousands of patients who've been treated with trigeminal neuralgia, that there's such a phenomenon as what we call radiomodulation. It's the idea that high dose, locally delivered radiation can alter, preferably downregulate a brain circuit. And this could be a next generation tool for neuromodulating the brain, following in the footsteps of deep brain stimulation. And so now, a scrappy, struggling startup that I'm supposed to be has ambitions in many ways that are every bit worthy of Stanford University. We are now 3 institutions in the world, 1 Stanford. We're playing with squid axons at the Marine Hopkins base, Hopkins Marine Biology Center in Monterey. We're working at Aarhus University, and we're working at National Taiwan University, treating pigs and soon monkeys, trying to see if we can understand, harness, and commercialize the idea of neuromodulation with radiation. A big story, but one that excites me to an incredible extent. In the end, this company that is now 4 years in existence and just got FDA clearance a year ago, is now commercializing around the world, has what I hope to be the best-in-class technology at an affordable price. We plan and want to kind of change the way most brain tumors are treated, make it much more accessible to the vast majority of people around the world. And I am committed, and we are already starting to explore huge uncharted vistas in the area of psychiatric disease, and really believe that this can be a meaningful advance in healthcare. But I want to emphasize, no matter how many lives you save, medical devices, and especially therapeutic devices, are overall lousy financial investments. I'll repeat again, lousy financial investments. I've been invested in multiple venture funds in medical devices over the last 15 years. The best of them maybe returned 15% return over 15 years. Most of them didn't even return my money. You don't go into medical devices because it's a great investment. And that's kind of why I want to point out something about universities and the medical device world, something incredibly relevant here to the biodesign program. I want to contrast what you do with what universities did in the state in trying to promote the stem cell initiative, which is great, wonderful. This institution particularly, and God bless Irv Weissman, I love the guy, they convinced the state of the voters of California to pony up ultimately was almost $6 billion to investigate stem cells, which is great. Stem cells are a great technology. But the voters were all convinced that what they were investing in was going to produce the fruits of their investment literally in a half a dozen years. But the $6 billion hasn't produced a single viable treatment yet. Maybe there's a bubble boy or two that is, in fact, going to be treated adequately. And I applaud what was done, but I want to contrast that with what is done inside the medical device industry that is hardly supported at all. In fact, I'm going to suggest that the public, as they voted for in that stem cell initiative, and the philanthropists who support Stanford University largely believe that they're supporting practical science that will have near-term clinical benefits. Yes, everybody would like to understand the human genome and in infinite variation and try to change the disease in 100 years. But what we do here is make patient lives better in the near term. And that's very important. So what philanthropists want is what we medical device people do, especially the biodesign program here. And I'd like to point out that they're not great investments. I went to the OTL office and I asked them about medical devices at Stanford and asked them how much money they brought in from license of medical devices. And I wish it was a big number, Paul, but it's paltry. And this is not a reflection on the importance. What I don't want us to measure ourselves, our value, is by money. But if you look at these, it's $138,000 a year. And yet OTL, from other things, from Moog synthesizers and things, makes $86 million over the average for the past 5 years. And philanthropy brings in just untold billions. So what I'm suggesting here is, do we really need OTL to be involved in this? Are we really making any progress? Now, there's a lot of people inside university administration who believe that medical device innovations almost requires a biohazard zone inside the medical device. It should be closed off. That's because they don't know anything about it. As Teddy Roosevelt said, I want to know about, teach me from the people who've dared great things. Teach me from the people who have attempted the near impossible, like the medical device industry. Because those who have understand the things I'm saying. We need to get off the backs of medical device innovators. So what I'm suggesting, I'd like universities to accept the fact that medical device is at the heart of their mission. It's not peripheral. It's what philanthropists want. It's what students want. Don't be afraid of it. It's way we can impact society. And I think medical faculty should be able to lead early stage medical device companies and beyond the faculty. That ability to live in both worlds makes you twice as effective and is good for the world. And forget this fixation with money shows you don't know what you're talking about. There is no money in this earth. There's a little bit of money, but you're missing the big picture. And so I would suggest that the tech transfer office if you have a medical device, let you do your thing. I have innovators come to my house once a month. We sit on my back deck and I drink beer with them. And they say, how should I deal with OTL? I mean, everyone's afraid of OTL. And in fact, they just get in the way. They don't produce any value for the institution or for the innovator. The world would be better off if they just let us do our things. What I can tell you about medical device startups having suffered and maybe not knowing much of anything is you'll swim incessantly in a sea of failure. You go to bed in a failure, you wake up as a failure. Every day your iPhone has 10 reasons you failed. You'll try to win, but most of the time you're going to lose. As the venture funds show you, most venture funds have the smartest people trying to manage venture funds in this industry of losing money. What happens to you will only make sense as you look backwards. And I'll tell you, as an old guy, you can still try to be special and still try to do audacious things. Only time will tell if I'm succeed or not. I'm just in the dustbin of failure. But I can tell you, it's the hardest thing you will ever do. The hardest thing. Cardiothoracic, pediatric cardiologist, Frank Hanley here. Anyway, the hardest thing you will do is this. Where I can tell you a lot about money and philanthropy, money and physician entrepreneurship. I'd say try to avoid working with a lot of greedy bastards, Varian and sometimes Stanford being cases of point. I mean, they just get in the way. There's no value. So money is a tool. It's just a tool. It is a very important tool. It's the lifeblood of innovation. But if you make it an end in yourself, you're a fool. You as a physician can make so much money. Why do this? Only you have to believe in the mission. I mean, I was never happier in life just being broke, hitchhiking in Alaska or, Guatemala. Never found that money made any significant impact in my life until I needed to start a company. But you know what? No one is going to understand these things about you and money. Everybody else, you did a startup because you want to get rich. And that's what the medical school thinks. The facts show farthest from the truth. And that's why I like medical schools to just let us do our thing. It's hard enough. What I learned as a physician CEO is that your power is amazing. And sometimes it's the only way to execute your vision. And that's why I became a CEO. Not because I have the ambition to tell people what to do. But I learned that the minute I wasn't CEO, shit happened. So non-physicians, I think, sometimes are afraid to push too hard in the clinical domain. As a physician, I'm much more comfortable pushing my physician customers or even patients. I think I can ethically know where the line is drawn in the sand. You have to commit yourself as a physician to at least 10 years. And you think 10 years is probably the minute. It's probably more like 15 years. And it may be more. You never know. And I'd say, do not build a medical device company because you want to make money and think it's an easy path. Do it because it's hard. Paraphrase Jack Kennedy. It's hard. This is hard stuff. I don't want to talk you out of it, but I want you to know what you're doing, and I want to applaud you when you do choose to do it. As a physician entrepreneur, you have a lot of responsibilities to your investors and your employees, and it's hard. To your idea. Ideas are special, they're fragile, and they change the world. To your patients. It's hard treating your patient knowing that, yeah, you've got a conflict of interest there. How far can I go with you? But I have to say, of all the patients I did really innovative things to, they all benefited. I mean, I was just lucky. And I can tell you, if I hadn't done these, there would be thousands of patients who would be worse off for it. So you also have a unique responsibility to yourself. If I'm going to invest 10, 15 years of my time and at the end have nothing to show, that's painful. That's painful. And that's what makes it so difficult. But if you don't do it, if you don't pursue these ideas, who will? And that's why today is important to celebrate all of us who have done these kind of things. How hard is it? Well, the greatest entrepreneur of our generation, he's crying out, will someone take my job? And he's not being facetious, he's being honest. I mean, even me, I would love someone to step up and take my job and do it. But when I tried it in the past, it didn't work out so well. So Elon, he knows that. And that's why it's important for many physicians to be entrepreneurs. The entrepreneurial life is the opposite of being a doctor, the opposite. As a physician, you go into the hospital, go in the operating room every day, you do your thing, you have fun, you're king of the operating room. Everyone does what you want or ask them to do. You feel like a hero. You walk out, you get worshiped. There's God, there's the doctor, and then there's everybody else. Families come out and worship you. And you do this 3 times a day. It's gorgeous. And I miss being a surgeon so much. I loved it. I still love it. But duty calls. And if I don't do it, who will? So if you're going to make this commitment, make sure you do something important. I see so many trivial inventions, and I'll throw one out just in a second. We do need physicians who'll step up and treat malignant brain tumors and ALS and chronic pain. So many unmet health needs. But they may not have reimbursement. They may not have a clear regulatory path. But if you don't do it, no one else will. And don't let reimbursement drive your innovation. We need patient care to drive it. And that's why physicians need to be involved in this game. And so here, Viagra recently came off patent, and now some enterprising entrepreneur is going to make money off that fact. Good for them. And that's what Silicon Valley venture capital has reduced itself to. But I was involved in this latter acquisition, Augmentics. So when I was at Varian, my job was to try to envision a world where surgeons were more involved in therapeutic radiation. And there was a company out of Boston, the innovator, smart PhD, developed a hydrogel, which we figured out could be injected between the prostate and the rectum, create a little bit of space, and make therapeutic radiation that much more effective. Seems like a good idea. But the problem is we didn't really need it. At this point, things like the CyberKnife were so effective, you didn't even need this product. But I said, I'm going to do something cynical in life. I said, I'm going to get involved in this company. I convinced Varian to invest $10 million because I figured that by giving urologists something to do, by them making some money, they'd embrace this procedure and start, kind of falling less in love with the Da Vinci, and then we'd see more therapeutic radiation used. So it's a very cynical thing I did, but I figured it was for a good cause. Okay? Well, turns out that this company was just acquired a few weeks ago for $500 million, then $600 billion, $100 million kicker. The world doesn't need it, but it was an incredible return. And that's unfortunately what so much of healthcare is. But we can't be cynical. And that's why, as surgeons, as doctors, we are the best people, the idealists, to keep the world honest. So this is my liquidity event. Not 100 million, 100 million lives. That's how we should define ourselves. That's how we should define our lives and our accomplishments. In the end, there's so many challenges in healthcare today, the most intractable diseases. But I believe unless physician innovators step up and become entrepreneurs, we will never solve so many of these problems. And the onus is on you and all of us to step up and deliver, because if we don't, who will? So I'd like to acknowledge ultimately the reason we do this is this. These are some of the patients I treated. And it's important to remind ourselves every day when you work on some regulatory pathway, some sort of financial thing, some sales thing, some kind of employment contract, whatever nonsense you're doing in your medical device company, that this is what you're doing it for. I think each and every one of these patients' life was transformed by what I was able to do for them. Not just me, but collectively. And this is the beauty of what we do. Not in 100 years, but now, the present. And these people speak to me. I hope they speak to you. So today, I want to thank Tom. I want to call him out. Today, what this is about, it's a celebration of medical innovation and entrepreneurship embodied by Tom. Tom, for how many generations, Tom? How old are you? For a long, long time, has embodied so much of the innovative spirit of this community. And he's done an incredible amount for the community and myriad patients. And I am humbled to be following in his footsteps and wish that I had but a tepid image of him. But around him, I surround him with all of you. Many of you have helped me. And to those of you who have, I deeply thank you. And I urge you to sort of look at today and look at today's celebration and say, yeah, it's a tough world, but if I don't do it, who will? And so together, let's go out and change the world. Thank you.
So don't you feel lucky to be here? 5 p.m. on a Friday, and you wouldn't rather be any other place on the planet. This has been one of our biggest Fogarty lectures ever, and now you know why. Now you know why you marked your calendar. That was a masterful lecture, John. And storied adventures to fuel the journey for all of us. And the takeaway lesson is, don't work for greedy bastards. So as each year, to commemorate the speaker, the idea of the young eagle taking flight, the flight of new ideas. Again, it's been such a fantastic lecture, John. We're so grateful.
Thank you.
Thank you so much.
The name Adler means eagle in German. Thank you.
All right, good. Thank you all so much. Really wonderful to have such a fantastic audience, and I hope you leave inspired.